All right, so this is part 2 of section 3.5, and we're just continuing with writing the equations of lines. So again, what do you need to find the equation of a line? You need a point and you need the slope. So let's look at this one. Write the equation, this time in standard form. So remember that's your ax plus by equals c of the line that goes through 5, 2, and is parallel to this line. So what are the two things we need? We need a point, we have it, and we need the slope. Well, if we know that our line is parallel to this line, we know that they have the same slope. So we have to find the slope of this line. So again, there are two different ways to find the slope. You can put this in slope-intercept form by getting the y alone on one side, or remember I said we could use negative a over b, but we have to be careful. Our equation has to be in standard form to be able to use this. Well, this is really easy to put in standard form. Standard form means we just want the x and the y on one side together. So I'm going to go ahead and I'm going to subtract 2y from both sides of this equal sign. So 2x minus 2y is equal to negative 3. Now I'm going to find the slope of this line by taking negative a, so that's going to be negative 2 over b, which is also negative 2. The slope of this line is 1. Now remember, our line is parallel to it, which means our line that passes through this point has the same slope. So the slope of our line is also positive 1. So now we have the two things that we need to be able to come up with the equation of a line. We have a point and we have the slope. Now I know it says we're going to put it in standard form, but remember, first we're going to put it in point slope form and then change it over to standard form. So point slope form would be y minus the y of the point equals the slope, which is 1, times x minus the x of the point. If I distribute, I'm going to get y minus 2 equals x minus 5. So now, again, we want standard form. Now that means we want the x and the y on one side. So do you see that means I'm going to want this x over here with the y. So I'm going to subtract x from both sides of my equal sign. And then I don't want this minus 2 here. So I'm going to add 2. So I'm just moving things around a little bit. So that's going to give me negative x plus y, the 2's are gone, equals, the x's are gone, negative 3. So this is almost in standard form. Remember, I also told you in standard form, we don't want any fractions. Well, we're good to go there. But we also don't want a negative a. And in this case, we have a negative a. We have this negative sign sticking out in front. We don't want that. To get rid of that, we're simply going to multiply through by negative 1. So that's going to give me x minus y is equal to positive 3. And there's our equation of our line that we wanted. Okay, so it's a lot of work. So let's look at number 5. Write the equation of the line that passes through the point negative 2, 5 and is perpendicular to x equals 6. Now, we have to be careful here because we're talking about our special types of lines. So this is a lot of just thinking. There's really no work to do here. Well, a little bit maybe. So we know that it passes through this point. What kind of line is x equals 6? Well, hopefully you remember that x equals 6 is a vertical line that passes through the x-axis at 6. This is the line x equals 6. Talk to me about a line that is perpendicular to that. What kind of line is perpendicular to a vertical line? Well, wouldn't it have to be a horizontal line? It would be. So I need the equation of a horizontal line that passes through this point, -2, 5. Well, remember, what does the equation of a horizontal line look like? It looks like y equals. It's not x equals, it's y equals. Look at my point. What does y equal? Y is equal to 5. Because remember, for a horizontal line, the y will always be equal to whatever the y of the point is. So in this case, no matter what point we have on a horizontal line, the y coordinate will always be 5. So do you see there is really no plugging anything into an equation? We didn't have to do that. We just had to look at what the slope meant. If it's perpendicular to an x equals, it means it's a y equals, and then we had to look at our point. Now, I don't have an example of this, but let's just talk about something for just a quick minute. What if it wasn't perpendicular to this line? What if it was parallel to this line? Well, if it was parallel to this line, wouldn't it have been another vertical line? Because since this is a vertical line, a line parallel would also have to be vertical. And if it went through this point, it would have to be x equals -2. Again, really no work to show. All right, let's move on to number 6. This will probably look familiar to you. Are the lines 2x equals y minus 3 and 8x minus 2y equals 2 parallel, perpendicular, or neither? We did some of these in our last section. I put them here, another one here, because I want to practice that m equals -a over b a little bit more. Remember in the last section we put them in slope-intercept form, but like I said, we don't have to do that. We can use this, and it's a lot faster. So let's use this to find the slopes of the lines, and that will tell us whether they're parallel, perpendicular, or maybe neither one of the two. So remember, if we use this, we need the lines to be in standard form. This second equation is already in standard form, so we're good to go there. This one, though, I need the y over here with the x. So I'm going to subtract y from both sides of my equal sign. And that's going to give me 2x minus y equals -3. So now that's this line in standard form. So now I can go ahead and I can find their slopes. Well, their slopes, the slope of the top one here will be -a, so that's -8, over b, which is -2. So the slope of the top line, the one with the 8, is 4. What's the slope of the bottom line? Well, it's -a, which would be -2, over b, which is -1. The slope of that line would be 2. Are they the same? Nope, they're not the same, so those two lines are not parallel. Are they opposite reciprocals of each other? Absolutely not, so the two lines are not perpendicular. So again, these two lines are neither one of the two. They just happen to be two lines. All right, so our last equation is a story problem. We did a story problem way back in our first section of Chapter 3, but I don't think we've done another one since one. So let's look at this one. A pool company learned that by pricing a new pool toy at $10, local sales will reach $200 per week. Lowering the price to $9 will cause sales to rise to $250 per week. Okay, so what that means is if it costs $10, they sell $200. If they cost $9, then they'll sell $250, which makes sense because the lower the price, the more they're going to sell. Assume that the relationship is linear and write the equation of the line in slope-intercept form. So to do that, I have a hint for us in parentheses. We're going to come up with 2 points. Well, I just kind of talked to you about the 2 points. One of the points will be 10, comma, 200. The cost of 10 will mean they will sell 200 of these pool toys. The second ordered pair or point is 9, comma, 250. So look what I have. I have 2 points that lie on this linear equation. So now I can go ahead and I can find that equation. So what are the 2 things I need? Well, I need the slope. So here we go. What's the slope of this line? Well, it's y2 minus y1, which would be 250 minus 200 over x2 minus x1, which is 9 minus 10. Well, what is that? That's 50 over negative 1. The slope is going to be negative 50. So let's, again, like we did before, let's first put it in point-slope form, but then we're going to write it in slope-intercept form. So we just need one of the points. Let's choose this one right here to use. So it's going to be y minus the y of the point, which is 200, is equal to negative 50 times x minus 10. Let's go ahead and let's put that in slope-intercept form. We'll first distribute. So that's going to be negative 50x plus 500. And if we add 200 to both sides, we're going to get negative 50x plus 700. So here's our equation in slope-intercept form. So now, something we might want to do, since we have, and we did this back in our story problem we did in the other section, since our values or our numbers stand for something, we might want to change the x and the y to 2 different variables that make more sense with the story problem. If you look at our points, what did the x stand for? The x stood for the price, right? And the y stood for the sales, or how many they sold. So the x was the price, and the y was the sale. So why don't we rewrite this equation, but this time instead of x and y, we'll use p and s. So what that means is that you can find the sales by taking negative 50 times the price plus 700. So it's the same equation, we've just changed the variable slightly. And that's going to help us when we go to part B. It says predict the weekly sales. So we're going to predict S if the toy price is $7.50. So if I use this equation, I can do a prediction about the sales. So it says predict S if P is $7.50. So how am I going to do that? Well, I'm going to take my $7.50 and I'm going to plug it in for P. But before we actually do the math, let's just kind of analyze it first. Remember when we looked and we read the story problem, the lower the price, the higher the sales. Remember that? As they lower the price, then they're going to sell more. So notice how they've lowered the price from $10 to $7.50. So hopefully it makes sense to you that the sales that we get should be much more than $200. In fact, when it was $9, it was $250. So it should be quite a bit more than $200. So let's see. So what is, I'm using my calculator here, 750 times negative 50. So that's negative 375 plus 700. it's $325. So what did we just find out? If they lowered their price to $7.50, then they should be able to sell 325 pool toys, which is much more than the 200. All right, there's the end of this section.